Okay, so worldwide, only a few crops deliver most of the calories that people are consuming, and that's wheat, rice, and corn, which is called maize in some areas. In cool and moist climates, they also often have potatoes, barley, oats, and rye. And in warmer, wet climates, cassava, sweet potatoes, and some other roots and tubers are also important sources of nutrients. So I mentioned before that there was this idea of the Malthusian catastrophe, and it was the idea that our population is increasing exponentially, but that our food resources are only increasing linearly. And so at some point, if we keep growing, our population will run out of food. So Esther Boserup in 1965 proposed a different model. She proposed that as the human population size grows towards carrying capacity, people will innovate and use technology to develop new ways to produce food more effectively and efficiently. And so her model looks like this, where population's increasing, food is increasing, so we're getting close to this crisis, and we have some innovations. We develop new technology, new ways of growing, and then we increase our production to a certain level, and it levels off. And then as the population keeps growing, we do it again. And that way we keep using technology and new ways of doing things, new information, science really, to revise our methods and produce more food in the same amount of space. So this is the kind of more recent huge change that increased yields is called the Green Revolution. This increased yields using research and technology initiatives from the 1960s, and that involved developing high yield varieties, expanding irrigation infrastructure, modernization of techniques, distribution of hybrid seeds, and use of synthetic fertilizers and pesticides. And so you can see here, this looks at a bunch of different crops, and it goes from 1960 to around 2010. And you can see that the production, and this is kilograms per meter squared, the yield. And so that's the amount of these crops being produced for the same area of farmland. So we didn't like convert more land into farmland here, which we certainly did some of that, but that's not what this graph is showing. This graph is showing that we increased the amount of crops produced in the same area of farmland across all of these different varieties. And you can see maize in green is corn, has really probably increased the most, but we see it across the board in all these different crops. And this graph over here shows the amount of yield, production, and area harvest and seed. So what we can see here is that the area of land harvest between 1960 and 2010 did not change very much. It might have even gone down slightly. And the amount of seed produced and added to the fields actually went down a little bit recently. So that's not the reason that we're producing more food. We're having yields go up and total production is increasing. And it's because we're producing more food from the same amount of land by using all of these technological innovations. So we can look at, this is total U.S. crop production. We have increased wheat and soy since the early 1900s, but corn has increased by far the most. And at the same time, we've seen U.S. commodity prices go down. So this is how much you can sell for the same amount over time. And this is all converted to 2010 dollars so that you don't have to think about inflation in this graph. And so you can see that some things haven't, the price has fluctuated a little bit, but it hasn't changed a lot. And this is chicken down here. And the same is probably true for wheat, but some things have gone down quite a bit, and corn is one of them. We're producing so much more corn, and as you can imagine, when something becomes much more abundant, then the price goes down. And so that's exactly what we've seen for corn. So next I want to talk about meat production. So there are costs and benefits to producing meat. So in developed countries, meat consumption has risen dramatically since 1960, and also dramatically since the 1800s. When we first invented refrigeration, people started eating a lot more meat because they could save it for later. They didn't have to eat it all in a day or two. And so it has risen from 10 kilograms per person per year in 1960 to 26 kilograms per person per year today. That is a huge jump. That's more than doubled. And so that's a large increase and a big change in our diets of what we're eating. And so this is in developed countries as a whole. In the United States, it's gone from 90 kilograms per person per year to 136 kilograms per person per year. So an increase, but you can see that we're eating a lot of meat compared to most other developed countries. This is the average. This is just in the US. Those numbers are much larger. So meat does have some benefits, especially in our evolutionary history when food was scarce. Meat was an important source of concentrated calories, concentrated protein, iron, and fats, and some other nutrients. So if you're in a place where there's not always a lot of abundant food, or you're not always getting all your calories, then meat was a treat that gave you needed protein, iron, and other nutrients. And because meat has a lot of fat in it, it has a lot of calories for the same volume being eaten. And so that means that, you know, it could save you from being malnourished if you were able to get meat. So that's why it tastes good to us, is because a long time ago, it was super helpful if food was very scarce, because it got you all those things in one little packet. And so that's what we wanted. Today, we're eating so much of it, though, it is causing some health problems, as we talked about earlier. Meat production is also a good indicator of wealth because meat is very expensive to produce. So it takes 8 kilograms of grain to produce 1 kilogram of beef. So 8 kilograms of grain is a lot. That's a lot of calories, actually. And we have to convert, if you'll remember back to the energy pyramid, each time we go up a trophic level, we're only saving 10% of the energy. And so if we're growing all of these crops to then feed another animal to then feed us, we're losing energy with each one of those steps. So it's more efficient to produce grain than to produce animal protein. We've changed a lot in how we produce meat worldwide, but particularly in the United States. Oftentimes when we think about meat and dairy being produced, we think of these small family farms with these happy cows eating grass and chickens running around. And you know, there's a lot of people, small farms that do still do that. Grass-fed beef is more what our image of the farm, what's in our kids' books. I have a little kid and we read lots of books about farms, and it looks like what you might have thought farms looked like 100 or more years ago, and what small family farms still look like today to some degree. But there aren't nearly as many of those, which we will spend more time talking about. So what most meat production is today is what's called a confined animal feeding operation, or a CAFO. This is where animals are housed in giant enclosures and fed diets of corn, soy, and grain so that they'll grow as fast as possible. A lot of these are mega farms. You'll find many houses of very packed in animals in a lot of these farms. And we have some chicken farms around Louisiana. So if you're driving around and you see a whole bunch of these long houses, some of you may be familiar with them. Those are example of these confined animal feeding operations. So these are common in the United States, Europe, and China. And we do this for most of our animals, but particularly chickens and pigs get put into these confined animal feeding operations. Beef is a little bit more variable, where they might only do that for part of the time, and they might be on pasture for another part of the time. We also have new breeds of livestock that have been developed that can produce meat very rapidly with very short turnaround times. So we can produce chicken in 8 weeks and beef in 18 months. There's also the heavy use of antibiotics allows producers to limit the spread of disease among animals being raised in such high densities. So anytime, and I think probably we all intuitively know this after COVID, that when you concentrate a whole bunch of individuals close together, if any one of them gets sick, if they're all, smushed together in a room or a stadium or a confined animal feeding operation, one of them gets sick and it's really fast for it to spread through all of them. So they use a lot of antibiotics in these operations to deal with that. So this just shows how much grain is needed to produce various meats. And so this is the kilograms of grain needed to produce 1 kilogram of live weight of animal. So obviously you could get 1 pound of bread from it's 1 pound, a kilogram of bread from a kilogram of grain. You could produce 1.5 kilograms. You would need 1.5 kilograms of grain to produce 1 kilogram of fish. You'd need 2 kilograms of grain to produce 1 kilogram of chicken, 3 kilograms of grain to produce 1 kilogram of pork, and 8 kilograms of grain to produce beef.